Unlocking the brain's secrets, a numbers game. The human brain is a mystery, a vast, intricate network of billions of neurons. It's the command center of our thoughts, emotions, and actions. How does it work? How do these neurons communicate? The answer lies in the language of the universe, mathematics. For centuries, we've gazed at the stars and wondered about our place in the cosmos. We've sought patterns and meaning in the universe. Mathematics has been our guide, our tool for understanding the laws of physics and the nature of reality. Now, we turn that same powerful tool inward, to unlock the secrets of the brain itself. By applying mathematical models and computational power, we're beginning to decipher the brain's code. We can analyze the electrical signals that zip between neurons. We can map the intricate connections that form our thoughts and memories. Mathematics is the key to understanding this complex organ. It's a journey into the very essence of what makes us human. The language of the universe. Mathematics and its building blocks. Mathematics is more than just numbers. It's a language, a way of describing the universe and its intricate workings. At its heart lie numbers, the fundamental building blocks of this language. Numbers allow us to quantify, to measure, to compare. They are the atoms of mathematics. From simple counting to complex calculus, numbers form the foundation of mathematical models. These models help us understand everything from the motion of planets to the behavior of subatomic particles. Now we're using these same tools to explore the inner cosmos of the brain. Think of a neuron as a tiny electrical switch. It receives signals, processes them, and sends out new signals. Mathematics helps us model these processes. We can analyze the strength of these signals, the timing of their arrival, and the patterns they create. Through numbers, we begin to decode the language of the brain. Neurons, the brain's tiny messengers. Imagine a bustling city, millions of people going about their day, interacting, communicating. That's your brain. Except instead of people, it's billions of neurons. These tiny cells are the building blocks of thought, feeling, and action. Neurons are connected by synapses, tiny gaps where signals are transmitted. When a neuron receives enough input, it fires, sending an electrical impulse down its axon, a long, slender fiber. This impulse triggers the release of neurotransmitters, chemical messengers that cross the synapse and activate the next neuron in line. This intricate dance of electrical and chemical signals is happening billions of times per second in your brain. It's how we perceive the world, learn new things, and control our movements. It's the foundation of consciousness itself. Where numbers meet neurons, a powerful partnership. Now, imagine trying to understand this bustling neural city without maps, without traffic lights, without any way to track the flow of people and goods. That's the challenge neuroscientists faced for decades. But now, mathematics provides the tools to navigate this complexity. Mathematical models help us understand how neurons interact, how they form networks, and how these networks give rise to complex behaviors. We can simulate neural activity, test hypotheses, and make predictions about how the brain will respond to different stimuli. This fusion of math and neuroscience, sometimes called computational neuroscience, is revolutionizing our understanding of the brain. It's paving the way for new treatments for neurological disorders, brain-computer interfaces, and even artificial intelligence inspired by the brain itself. Section 5. Transforming Lives: Real-World Applications of Neurotechnology. The intersection of math and neuroscience isn't just theoretical. It's leading to real-world applications that are transforming lives. Take, for example, brain-machine interfaces. By decoding neural signals, we can now allow paralyzed patients to control robotic limbs with their thoughts. Imagine the possibilities. Restoring movement to those who have lost it, allowing people to interact with computers and devices using only their minds. This is the power of neurotechnology, and it's just the beginning. In the field of medicine, mathematical models are helping us develop new treatments for neurological disorders like Alzheimer's and Parkinson's disease. By understanding how these diseases disrupt neural circuits, we can design drugs and therapies to target those specific circuits and potentially slow or even reverse their progression. Section 6. The Future of Neurotechnology, a glimpse into tomorrow. The future of neurotechnology is brimming with possibilities. Imagine a world where we can treat mental illnesses with the same precision we treat heart disease, a world where we can enhance our cognitive abilities, improve memory, and unlock the full potential of the human mind. This may sound like science fiction, but the seeds of these technologies are being planted today. Researchers are developing new brain stimulation techniques to treat depression, anxiety, and even addiction. They're creating artificial intelligence systems that can diagnose neurological disorders with remarkable accuracy. The convergence of mathematics, neuroscience, and computer science is ushering in a new era of understanding and manipulating the brain. The possibilities are as vast as the universe itself. Section 7. The quest continues, unraveling the brain's mysteries. We've come a long way in our understanding of the brain, but the journey is far from over. The brain is the most complex object in the known universe. Unraveling its mysteries will require continued exploration, innovation, and collaboration. Just as we once looked to the stars and wondered about our place in the cosmos, we now look inward, to the vast universe within our own skulls. The quest to understand the brain is a quest to understand ourselves, our consciousness, our very essence. It's a journey that will require the combined efforts of mathematicians, neuroscientists, computer scientists, and engineers. It's a journey that will push the boundaries of our knowledge and technology. But the rewards are immeasurable: a deeper understanding of the human mind and the potential to alleviate suffering, enhance human potential, and unlock the mysteries of consciousness itself. Section 8. Bridging the Gap, Collaboration for Breakthroughs. The quest to decode the brain is not a solitary endeavor. It requires a symphony of minds working in concert. Mathematicians provide the tools and frameworks to model complex neural processes. Neuroscientists bring their deep understanding of brain structure, function, and dysfunction. Computer scientists develop algorithms and computational power to analyze massive data sets and simulate neural activity. This interdisciplinary collaboration is crucial for driving breakthroughs in neurotechnology. By breaking down the silos between disciplines, we foster a cross-pollination of ideas and approaches. Just as the human brain relies on the interconnectedness of its billions of neurons, so too does scientific progress depend on the interconnectedness of diverse minds. By fostering collaboration and communication, we can accelerate the pace of discovery and unlock the brain's secrets faster and more effectively. Section 9. Ethical Considerations in Neurotechnology. As we venture deeper into the realm of the brain, we must proceed with caution and foresight. Neurotechnology has the potential to revolutionize our lives, but it also raises profound ethical questions. Who will have access to these technologies? How can we prevent their misuse? We must ensure that neurotechnology is developed and deployed responsibly, ethically, and equitably. This requires open dialogue between scientists, ethicists, policymakers, and the public. It demands careful consideration of the potential benefits and risks of each new technology. Just as we have developed ethical guidelines for genetic engineering, we must do the same for neurotechnology. The goal is to harness the power of these technologies for good, to alleviate suffering, and to enhance human potential, while safeguarding against unintended consequences. Section 10. The Promise and Potential of Neuro-Inspired AI. One of the most exciting frontiers in neurotechnology is the development of artificial intelligence inspired by the human brain. By mimicking the brain's ability to learn, adapt, and solve problems, we can create AI systems that are more powerful, efficient, and intuitive. Imagine AI systems that can assist doctors in diagnosing diseases, personalize education based on individual learning styles, or even compose music and create art. These are just a few examples of the transformative potential of neuro-inspired AI. By understanding the principles of neural computation, we can design AI systems that go beyond simply processing information. We can create AI that learns from experience, adapts to new situations, and exhibits creativity and problem-solving skills that rival our own. Section 11. A Call to Action: Investing in the Future of Neuroscience. The journey into the brain is a journey into the future. It's a journey that holds the promise of transformative breakthroughs in medicine, technology, and our understanding of the human mind. But to realize this promise, we must invest in the future of neuroscience. We need to support research, cultivate the next generation of neuroscientists, and foster collaboration between academia, industry, and government. We need to create an environment where innovation can flourish, and where the ethical implications of neurotechnology are carefully considered. By investing in neuroscience, we're investing in our future. We're investing in the health and well-being of generations to come. We're investing in the quest to understand the greatest mystery of all, the human mind.